Hi Heidi, hi Anton. Glad to see you both
Hello.
today.
It's good
Hello.
to be here.
Great. And before we start, let's just start with a quick talk. So, Heidi, you're speaking about features, microservices, and so on. But this is the part of the bigger picture. And usually, when we're speaking about DevOps practices, we're starting with continuous integration and continuous delivery. There are a lot of misunderstanding around those ideas. What is your take on those concepts?
The thing I want everyone to remember is that continuous integration can happen all the time without doing a release. When we say we want to do deployment, it doesn't necessarily mean that it's live in public. And so I think it's really important to think that all of the resistance, the pushback against doing CI/CD is about I don't want to release to the public all the time, but you don't have to be doing CI/CD. As long as you can integrate and get stuff out onto production, you don't have to release it. And I think that's so key to understanding how so many companies can make CI/CD happen.
Okay, what is the biggest threat in doing CI/CD in a company? What is the biggest pushback?
The biggest pushback is that people really feel like they don't have control over what the user experience is going to be like. Like if you put something bad in production, that may affect users. And we all want to keep our users safe and happy, so we tend to be very controlling about what gets put on production. But the important thing is not what gets put on production, but what gets executed for users. Because you can't test anything unless it's in production.
Especially with
You
load
can
testing,
do
yeah, I believe.
Yeah, you can do unit test, you can do integration test, you can do end-to-end test, but it still won't tell you how your microservices and APIs are interacting.
Right.
Yep.
Yeah. Nothing like the real thing.
Okay, Anton, I believe you helped a bit with this talk in particular. So what was the biggest change you introduced in the talk so it is more accommodated to DevOps conference attendees?
This talk.
Yeah.
Yeah. Well, if I understand your question correctly, the main difference about this talk will be that I'll be interjecting. I'll be basically interfering with Heidi's talk because we want to make it more interactive. We want to make it more unpredictable. Exactly the same way as rolling out to production is.
Sounds exciting. So let's begin then.
All right. Thank you for joining us. It's good to have you here and have you with us. If you are just joining us, I'd like to point out that after this talk, we're going to have a group discussion in a Zoom. There's a link available to you, and we also welcome questions in the Telegram chat. So, Tinkertoys, microservices, and feature management. How are we going to build for the future? When I was a kid, I got this kit, and it was possibly one of the most frustrating things in my life because every time you put a part of it together, it changed how all the other parts worked. It meant that if you got one thing a tiny bit wrong, instead of the marble doing a loop-de-loop on the rails, it would fly off and hit your sister in the head, hypothetically. And it was really frustrating for me to try and put together. I ended up asking a friend of mine who is a literal rocket scientist at JPL to help me out with it, and it still took us 2 days. And the interesting thing about this toy is I didn't realize then what a great metaphor it is for trying to release software. Every time you change something, you change the whole system. And that's really important to understand. that's like what software is like. And this is a really simplified drawing of like a software architecture. If you think about how your software architecture looks, it probably isn't even this tidy. But when you change something in it, it changes how the whole system responds. And that makes it super difficult for us to predict the behavior of things, especially if they're tightly coupled, if they are interconnected. We keep talking about how we're doing microservices so that everything works independently. But in practice, what a lot of us are building is actually a distributed monolith, where if any of the microservices are down or not responding, we still have a problem. It's just more isolated, and it might be a connection problem instead of a problem with the service itself. So let's talk about where software is right now. We're going to say that software is complicated, and what we have is a historical artifact of what we had to start with, which is appropriate. We have moved the locus of control in computing. So let's go through this brief history of computing, because I think it's useful in DevOps to understand and remember where we came from. At first, we were programming things with transistors, with cards, with physical objects. We had these things that we touched, and they would return a predictable outcome when we plugged them into computers. And then we realized that this would all be a lot more efficient if the first thing we wrote wasn't how to make everything work together. If we could standardize our drivers, if we could have uniform responses from hardware. So we invented operating systems. And operating systems allowed us to say, this computer is going to behave pretty much like this other computer. And we have a predictability and a reliability with that. But then we realized that we could move on even from that. And we could do a virtual machine where we take all of those drivers and all of those operations and we make them virtualized so that we could put more of them on a single computer, because the important thing wasn't that it was on a machine. The important thing was that it thought it was on its own. Then we realized that if we don't really have computers, we don't need drivers for like network cards, and we don't need like virtual printers. We could just have a container that contains the things that we need to do and nothing else. We could strip it down so that it was much more efficient to put more of these containers on a computer and then have just one thing administering all the network ports. And this is an interesting example because we just saw that Docker is no longer going to be fully supported. Well, Docker shim is no longer going to be fully supported on Kubernetes. And that if you have Docker containers on Kubernetes, they're going to break. Not because Docker itself is broken, but because Docker is too much operating system for Kubernetes to really need. And so the Kubernetes people are trying to say, strip down this virtual machine / container into something that's even more efficient, because we don't need a lot of this stuff that's in Docker shim. And then we got a whole bunch of containers and we wanted them to do different things. So we're talking about like, how does orchestration work? How do we get containers that are identical and replicable, but also some of them need to be like load balancers and some of them need to be doing execution? And how do we pull all that together? And then finally, where we are now is serverless, which we all know is not serverless, but is a way to think about abstracting actual computation away from what does the computation. That we start thinking about what a function is instead of what the function needs. And I think that's a really exciting advance. We're going to find out a lot more about that in years to come, but it's definitely an evolutionary step along that same path. The future is fractal. It is so confusing every time you look at like how computers work. You come to understand that every bit that you understand is just a surface layer, and you could dive even deeper into knowing what's going on. And I think that's both exciting and a little scary, because every time you learn something, what you learn about it is that you don't know everything about it. And how do we operate in a world where we have to go around not knowing how almost everything that we use in our day-to-day life works? Like, I drive a car, but I can only barely explain how internal combustion works, and I definitely cannot explain how airbag sensors work. I just have to trust that they work. When we think about that in terms of computing, we're trusting a lot of people to do the right thing and to get it right. And if there's one thing that we know about humans, is that we don't always get it right. Operational is not the same as perfect. If you've ever gotten on a flight and it's been delayed because of something stupid, like the overhead door latch doesn't work, or one of the bathroom doors is wonky or something like that, and you thought, why can't I take off? This plane is fine, and it's just like a luggage bin. Well, the thing is, airplanes have an error budget. And it doesn't matter what exceeds that error budget. If more than a certain percentage of things on the plane are broken, we have to assume that the core maintenance that keeps the plane in the sky may also be broken. And so we pull it out of service. And this is a way to say, like, there are always things that are broken on the plane. The hot water heater for the coffee is not working right, or like not safety critical things, other things. If it's safety critical, they pull it right away and it makes sense to us. But the other things indicate that the plane may not be getting maintained to the level that it needs. That doesn't mean it wouldn't fly. I also think about this in terms of human bodies. We can do a lot of things with imperfect bodies. Most of us sitting here in front of a computer monitor have imperfect bodies. We're not ultra marathoners. I mean, maybe some of you are, but lots of us have like wrist braces or other things that we need. We need glasses to help us get through our day. That doesn't mean we're not operational. So when I'm thinking about how to design a system, I want to design it so it doesn't have to be perfect. I want to design it with some slack, some flexibility, so it doesn't have to be perfect. This is actually a testing talk. I never say that up front. I wait until I've sucked people in and made sure they're really committed to it, and then I give them a bam, this is a talk about testing, because it turns out that testing is what we need to understand in order to make our services more awesome. We have to ask ourselves, why do we test? What is it that drives this testing behavior? And a lot of times, the answer is because my boss told me to, or because I'm scared of what will happen if I don't test, or because I don't want to get paged. And those are all reasonable answers. But I think it's also really key to think about testing as putting ourselves in the place of the user and making sure that the user has the safety of somebody having done this before them. What we're really doing testing for is to make sure that the user experience, no matter how far downstream it is going to be okay. So when you think about why we test, it makes more sense if you're thinking, how can I help the user?
So
what
would you say, Heidi, that testing is about empathy?
I would say that testing is about empathy, like in the large spectrum, because it's hard to test for somebody who you don't know what they're trying to do. And I think this is one of the things that Agile really drove home, was that you should be writing a story about what the user wants to do. And if the story is an administrator wants to use OAuth, you've kind of gotten it wrong. I think we've all seen stories like that. But what we're actually trying to say is the user wants to be able to use their fingerprint on the phone to log into their bank. And OAuth is a part of how we make that happen, but really empathetically, what we're trying to do is help people in their day. Kathy Sierra said something really great about this in her book, Badass, Making Users Awesome. She said, nobody wants to use software. We want to do the things that you can do with software. We want to find a Pokemon. We want to create some graphics. We want to, locate a bank. None of those are like, I would like to sit down and use software. I think even those of us who work in software are like, I would like to figure this puzzle out. I would like to get paid, but it's not really like the joy of software itself that drives us. Does that answer it?
Yeah, I suppose so. But that's interesting because that's a great question. Why do we test? We don't ask ourselves that too often. So I started thinking about this, and I'd say I test because I accept my own lack of perfection. I understand that I'm human, and first of all, many of the things, the features that I implement, I cannot understand them in their completeness because I just cannot grasp the complexity of the thing as a whole. I need to test it bit by bit in order to be sure that what I did is exactly what I meant to do. And the other thing, I realized that as a human, I'm prone to make errors. So if I don't test it, how can I be sure it's working?
Right. And I think that thing about empathy is like, what drives you to care about whether it's working? If you could turn out code that no one ever used, but you still got paid for, would you find that satisfying?
No, because that's
Right.
the payment is not what connects me to the fruits of my work. We were actually talking about this yesterday. We're always recalling Marx here, being
Right, I was
connected
going to
to the
say,
fruits
like
of your labor.
Yeah, exactly. In English, it got translated as alienated from the product of your labor, which I think is a great way to phrase it. And I think that testing drives us to think, if we're doing it right, drives us to think about the product of our labor and how it impacts others. So it's so easy to get in this rote of, well, I ran the automated tests and I don't need to worry about it anymore. But that's not why we're testing. We're testing so that it's usable for people. So what do we test for when we're doing testing? Like, how do we know we're testing for the right things? Charity Majors says this thing that I just love. I have this slide in so many of my talks, and she says, nines don't matter if the user is unhappy. And it's this great SRE reflection that says it doesn't matter how stable your system is for metrics if you are not serving the user with what they want. If you are not delivering user experience, none of this matters. And if we keep that at the core of our thinking about how we develop software, I think we do a lot better. And DevOps is really this intersection of how does software work and how do we deliver it? And without both of those parts, we're not really doing anything interesting. The trouble with testing is that it's toil. And this is defined in the SRE workbook by O'Reilly. But I think that we're becoming familiar with this concept. So toil is work that is manual, repetitive, automatable, tactical as opposed to strategic, has no enduring value, and scales badly. And I think we can all think of things that we've done that are like this, where you run a bunch of automated tests and they come back with an error, but it's the error you know about, so you don't even look at it. It's like, oh no, my disk is filling up again. If you don't pay attention and figure that out, either you have to scale your disk or you have to just like automatically delete a bunch of stuff. But if you don't dig into why that's happening, then what you're doing is setting yourself up for more toil. The problem is a lot of the work we do in SRE and DevOps is manual and repetitive and automatable. It's responding to break fix. It's emergencies that you know are going to happen. It's Black Friday has crushed our servers again. Like I would say I can't believe that Amazon US East 1 went down on Black Friday, but I totally can because we know that for the US, Black Friday is an intense network event, and we're asking a lot. And so what happens is that no matter how much you try and respond to it, you're still acting on a tactical level. You're still trying to fix Friday instead of trying to fix 2020 as a big picture item. So when we think about toil, we think about
can anybody
go
fix
ahead.
2020? That's the question.
No. 2020 is kind of a lost cause, but I think that we can look at it and say which companies did a good job scaling out. Like Zoom struggled for a little bit, but then like wherever they bought the bandwidth, it worked. And a lot of companies had to switch very suddenly how they did their work, and a lot of them succeeded. So I think it's useful to look at the lessons of 2020 and say, okay, how does working from home work when we're all used to like talking to each other over coffee to solve problems? Well, now we need a different way, and that makes us more resilient. But no, 2020 is not fixable. So what constitutes a useful test? Like, how do we know if something is a useful test? It needs to be end to end. We do have to do individual unit tests, like you were saying, Anton. Like, I need to understand that each part of this works. But we also need to make sure that the whole thing works end to end and that a message transits in a reasonable period of time. And that is a harder problem than you think, and people have been working on it for a long time. Like my job in like 2002 was about message queuing and how to monitor it, and that hasn't really changed. We test for availability. If somebody is trying to reach our systems, can they do it, and can they do it in a reasonable time? How long does it take to get a response? Are the responses that they get accurate? I think that's something that's easy to forget. You're like, oh, ping sending something back, it's all good. Well, ping is not big. What I want to know is if somebody is getting all the parts of their movie. Are they getting, Spanish subtitles as well as the main picture? Both of those things are important. Is it usable? This is something that we frequently leave out of testing. Usability and accessibility are in fact important for people to have an end user experience that is useful to them. And I think we forget that not everybody is us. And this is another thing about empathy. It's easy to forget that we're just very good at computers. There's a joke that goes around Twitter at this time of the year, and I don't know if it translates, but it says, in the time of Caesar Augustus, all return to the homes of their birth and reset the password on the Wi-Fi router. And I feel like that's so reflective of how we experience life. Like we go back to our parents' house and fix their technology at Christmas because that's when we go home. I don't know how we're going to do it this year. I think a lot of people need to learn RDP very fast and talk their parents through installing it so that they can patch their parents' computers. But usability matters not just to us, but to less expert users.
Actually, with Zoom, you don't need RDP.
Yeah, but can you fix like their settings? Can you patch their system over Zoom? I'm not sure. We all know that our parents have turned off the automatic patching. So tests that aren't useful, but we do. Code coverage. We used to care about code coverage and how much of your code was covered by a test, but we also used to care about server uptime. And that is not a valid metric that we care about anymore. Nobody's like, hey, guess what? My server's been up for 4 years. That used to be actually a really awesome sign that you were a great admin. And now it's really worrisome because we've changed how we think of server maintenance. In the same way, 100% code coverage just tells you that somebody has checked a box. It doesn't tell you that your code is working correctly. We make the mistake of only testing the happy path. Like, this is the way the software is supposed to work, so I'm going to test that. Like, yes, you have to test that, but you have to understand that users are like the greatest force for chaos ever invented. And they will think of things that you don't think of. I think this is where a really good tester, a human tester, comes in. They write test cases that would not occur to the people who write the software. And I've seen a decline in the number of organizations that have human testing, and I think it's troublesome because we need that kind of weird sideways brain. The same kind of brain that makes a good security pen tester makes a good like testing suite composer, because they think sideways to how many developers think. We make the mistake of testing only clean data. We know what characters are and aren't allowed, and therefore we only test with data that makes sense to us. For years, like since 2014, I've been saying that we are coming up on the age of emoji-named children. And I would really like to thank Elon Musk for proving my point. Probably not so much in Russia, but in the US, we do not have very good extended alphabet support. And so when he gave his kid a name that had a letter that doesn't occur in our character set, a lot of news organizations sort of barfed on the name because they don't have a way to represent that. Nobody has said, hey, what happens if you have that AE diphthong, out there? And then the last thing that we test and think we're doing okay is we test on staging. And it's important to test on staging and to say, like, does this work end to end? But staging is not as weird as production, unless you're going to set up complete second accounts with the data flowing through it and the API calls and the dependencies and the noise of the network. Your staging is not representative of what's going to happen to your code. So I think it's really important for us to understand that we're not done testing when it passes on staging.
Yeah, actually, some folks go as far as say that staging can be actually so much misleading that you better not have any staging environment at all. In fact,
Yes.
if you can do the testing in production, why have staging? Why have staging?
I think it's a comforting lie. Like, we believe it and it makes us feel better, but it's comforting, but it's not true. So if that's where we are now and where we've come from, what does the future look like? The future is self-healing. I read some books on this. Mark Burgess has a lot to say about self-healing networks and understanding what's going on. Those books are super dense, and I'm waiting for somebody to write like the dummy's guide to Mark Burgess's thinking, but it hasn't happened yet. But what he's saying is we have all the tools that we need to detect problems. So why are we causing people to have to fix them instead of automatically fixing them? For example, one of the things that I talk about people using feature flags for is data overrun. So you are a company, almost all companies have at least some API streams coming in, writing to a database, right? Stuff is coming in. It's coming in from Salesforce, or it's coming in from your vendor, whoever it is. If there is a sudden like 100% or 100x spike in traffic, something has gone wrong. And you would like to quarantine that data and double check that it's good before you ingest it into your database. Frequently, this is like a botnet behavior where somebody is doing like a DDoS. And if you let all of that traffic into your network, you have a much greater chance of taking the whole network down. And if you wake somebody up to do it, it takes them time to wake up, log in, understand the problem, and switch it off or switch it to quarantine. If you set up a feature flag tied to your detector, whatever kind of monitor you have, that can all happen automatically, like a circuit breaker. So instead of having to do that, you can say, okay, something weird is happening. I'm going to take all this data and quarantine it off into a bucket, and I'll take a look at it in the morning when I'm smart. And I think that's a really powerful way to talk about a self-healing network, that it responds to monitoring by itself in the way that we've set it up. I think that the future is really redundant. So this is a picture of Toronto after they had a tornado, which is not a thing that happens a lot in Toronto, Canada. It was pretty surprising. And the tornado managed to hit in the worst possible place for their power distribution. This is the substation that takes in power from like 3 hydroelectric dams and distributes it to the city. And they lost that central station that did the power distribution. Now, the dams were fine, and a lot of, not all of, but a lot of the distribution network was fine, but they were missing that middle piece, that splitter that took the extremely high voltage stuff and split it out into, substation and household amounts of electricity. What they ended up doing was routing it through a bunch of smaller stations, smaller substations, to get electricity out to people who needed it. They knew that by doing so, they were running those substations at higher than rated capacity, and they were going to burn those stations out eventually, much sooner than they would have otherwise. But they had the capacity to run those at a higher volume, at a higher voltage, and get electricity out. And I think that's such an amazing story of how we should think about this node and spoke capability of our own programs. Because sometimes we do lose like that one giant microservice that we depend on. And have we left enough capacity in all of our other services so that we can shuffle things around a little bit? In the beautiful future, semantics are more important than syntax. And I write and talk a lot about semantic HTML, which I think is so cool. It's designed to be the HTML that is read by machines, but it turns out that machines are representing people. So semantic HTML is not just like your heading looks bold, but it knows that it is bold. And so it can be represented in a number of different ways. Like a screen reader might read it more loudly, or you might be able to skim down headings instead of having to go through all the text. Anyway, semantics are a thing describing itself. And we get into a lot of ontology, which we're not going to do right now, but it's interesting. Syntax is very prescriptive. It says this heading is bold because I have made it bold, but it doesn't say anything about what the heading thinks of itself. This is a picture of a Mars rover that landed in balloons. Now, we didn't know exactly how it was going to land when we sent it to Mars. Like, we were pretty sure the balloons were going to keep it safe, but it's a physics simulator, right? Physics simulators used to be very difficult, and now they are so easy that somebody has invented like this wacky goat game that has extremely, I'm trying to remember the name of the goat game, has extremely weird physics where the goat can just lick things and stick to them with its tongue. And like the idea of using a physics engine for this child's game is so amazing because nobody had to program how the goat licks things and sticks to them, or how the Mars rover bounces, or how the angry bird arcs as we're shooting things. That's all a physics engine that says, this is how the rules of the world work. You figure out how to do it because you have the compute power. I'm just going to tell you the rules. I think in the future, we're going to get better at defining the rules of our world rather than trying to say, like, goat licks this down 10 degrees. I think that's a really exciting way to think about where we're heading.
That's interesting.
We want,
I also like, yeah, I also lately find myself talk about semantics a lot, mostly in the context of continuous delivery and continuous deployment, and the semantics of the change. Actually, the dichotomy I'm using is semantics versus mechanics, right? So there are the
yes.
mechanics, and the mechanics are simple and understandable. This is thing from here to there, but why you're moving and should it be moved, this is the semantics.
And it's interesting because at a high level, the semantics are easier to grasp when you say, this is why we should move things from here to there. And the semantics are the abstraction, and the mechanics are the execution. And I think as people who are in this space, we need to start paying attention, because that means that if you have a good semantic outline for your CI/CD pipeline, you can switch tools. You can say, I already know how it's supposed to work. I just want to change the underlying mechanics.
Right.
Theoretically. I don't think we're there yet. But it's interesting if we dig into it, like, what are we trying to accomplish and what kind of thinking do we need to do it?
Yeah, and how we need our systems to become smarter and to understand better what we mean for them to do.
Yes. Yeah, the wonderful thing about computers is they'll do whatever you ask them to. And that's also the terrible thing about computers. They never say, stop, that seems weird. I don't understand. Like, what? That's not what you told me to do last week. They're not there.
Yeah, what you told me
Another
to do is not
thing,
what you meant to tell me.
so many times. Computers and I have an adversarial relationship. So when we're testing, what we want to test is the experience and not the embodiment. This is the same thing that you're saying about, the mechanics. So if you go to a doctor, the doctor is not going to say, how does your thyroid feel? Because you can't tell how your thyroid feels. The doctor's going to ask you, how's your energy level? And how's your hair? Is it thinning? And how's your skin? Is it brittle? And if you show up with a bunch of signs that you might have low thyroid, then they will test to see if you have thyroid stimulating hormone. We can't directly test to see if you have the right thyroid stuff easily. A little bit, but not much. Instead, the thing that we do is say, does your body think you need more thyroid? And if it's trying to make more thyroid and not succeeding, then we go ahead and give you a supplement. So it's like this really indirect path that says, what are you experiencing? And what are the mechanisms that indicate there's a problem, rather than saying, hey, thyroid, how are you feeling? It's not how it works. And I think that's true of a lot of our systems, is we don't have a good way to say, like, are you computing too hard? What we say is, like, this computer is running very hot, or the load is slowing down, or the cache buffer is not great. It's not that we have this direct understanding of what's going on. I think when we're testing, it's really useful to find the things that indicate there's a problem. So I promised you Tinkertoys. I don't know if Tinkertoys are a thing where you are. So let me show you a picture of Tinkertoys. Tinkertoys are these little hubs and spokes. And you plug the spokes into the hubs and you build all of these fantastic building toy things. I had Tinkertoys when I was a kid. It's a very, like, nerdy building toy thing that's differently complicated than Legos. The thing is, you can't build anything fun with just half of this. frequently when we think about microservices, we're thinking of them as the hubs. And if all you have is hubs, you just have a stack of little round wooden things. Nothing exciting happens. It really matters that you have all of those pegs that go between them to actually build something. And it's so easy for us to get stuck on testing just our microservices and not test the channels between them. It is so easy because you're like, oh, hey, microservice, how you feeling? And okay, you're fine. But we haven't tested the channel through. And we haven't said, like, can this bear the capacity or overcapacity of what I want to send through it? Is it 100% accurate going through it? Is this channel doing what I need it to do? And so when I talk about testing microservices, I think it's really important to say, test the ways that your microservices are connected, because it's a thing we forget really often.
But Heidi, wasn't this the whole promise of microservices? Each microservice can be tested in isolation. So if it's tested well enough, you don't have to worry about its surroundings.
Right. They're all isolated, except for the part where you kind of need them to work together. Oh, we forgot that. So when you talk about microservices, very few people talk about like their channel throughput or their connection. They're like, there's an endpoint. Okay, what? It's not an end. What does the endpoint connect to? Is that working out right? Is that a thing that we're happy with? So yeah, they promised us microservices would be easy, and they aren't. They are just differently hard. And anybody who believes that something in computing is going to be easy doesn't understand how much we've already abstracted away. Like every time you use a language, you don't think about the fact that it's a compiled language on top of another language, on top of machine code, on top of some weird ass
standard library,
electrical engineering stuff. Go ahead.
No. Just spilling some of my pain about the standard library.
Right. So we can't think about that because, like I said, it's all fractal. Like the more you understand that you don't understand, the scarier the world gets, because you're like, oh, what do you mean there's a security vulnerability that has to do with how my chip is constructed? And then somebody figured out a clever way to make the chip go faster by doing not conditional execution, speculative execution. And like one line of this microscopically tiny thread of wire can overhear the next line, and now I have to change how my computer works so that it's slower. What? Like the Heartbleed and the speculative execution attack system is so mind-boggling to me because it's so far down in our stack that we never thought about it as a problem. It's cool, but also terrifying.
Yeah, these are the problems that are the hardest to solve, but also the most fun to solve when we succeed to solve them.
Yes. So when we're thinking about plugging all these things in together, our microservices, their microservices, what we have is frequently APIs. And APIs are just a specification that says, this is what size it's going to be. Nobody can, like, you can make fake Legos. Lots of people do. They may not have the same feel because of the process that actual Lego uses, but these are known specifications, and you can make something that plugs into them, and people do. And that's what we're talking about when we're talking about interoperability, that you have specified what your endpoints are. And one of the things you need to test is whether your endpoints are accurate. Like, are you Lego knockoffs so cheap that you don't actually connect to real Legos? Well, then you're not any good. Nobody wants to use you. The problem with microservices and feature flags is that there is a combinatorial testing complexity. Every time you add another element, it gets harder to understand the testing and more impossible to do full testing. And my GIF isn't working, but it's an orbital model of two bodies, not even a three-body problem, a two-body problem. And it is so complicated to see what's happening at every moment in time, even though this is actually pretty predictable. So one of the things that I get pushback on when I talk about feature flags is people are like, how do I test that? Every time I add even a binary flag, I've doubled the number of testing paths. And I just can't handle having that many paths to test. I'm like, that's a fair question. I don't think you should have full testing, but that's me. What we need to test is not whether each of these connections is solid, but whether the whole is working as a whole. So if you set something on top of this Tinkertoy construction, it would hold because it's structurally sound. And that's what we're testing. That's why I'm emphasizing like the user testing, the embodiment testing, what it's like to have this. Like if one of those connections is loose and it's not load bearing, I don't care. It is sufficient that it is there and working right now. So when people ask about adding a Boolean flag, a binary flag, here's what I tell them about a testing plan. When you test your flags, you test them all on. And this is a very noisy option. Like, this is not something that would ever happen. But you need to know that they all work at the same time and they don't conflict with each other more than you expect. You test them all off. Does turning everything off break your site? That's something you need to know. You test the status quo. What is your software working like before you add this flag? If you don't test that, you're not really doing good science because you don't have a control. And finally, what is the status quo plus or minus this flag change? And I think it's useful when I'm talking about this to say that I think of flags in two different ways. There are permanent or long-lived flags that are load-bearing. There are things like operation circuit breakers and entitlements that give people permission to the site. Like if you have somebody who's registered for a site, they always get in without the firewall. That's a permanent flag. Things like that. If you have a temporary flag, it's a rollout flag. It's something that you're not going to leave in your code forever. And you need to test both of them, but they sort of have different levels of rigor. Like if you have a rollout flag that says we're going to try a new feature for just the beta group of users, and something in that flag is broken, you just roll it back and it's not a big deal. You're like, okay, fine, let me try that again next week. If you have something broken in a permanent flag, it's a bigger deal because you were relying on that flag for how your infrastructure works. And I want you to do it all in production. I've talked about this a bit, and Ton has talked about this a bit. Staging is a comforting lie. And if you're not doing something in production, you're not getting the full weirdness of all of the connections in our world. When we set up these calls, we had to do, like, at the same time of day, roughly, figure out how it's working on my internet, because in the moment, we tested as much as we could in staging, but then when I came online again today, we needed to test it again because it was a different setup because it's live in production. And both of those were important. We changed things at both testing places. So when we're doing something in production, we're always going to learn about how it works in production in a way that we can't about how it's going to work in staging. Oop. Oh well. So complexity has inherent problems and it's very hard. So now that I've terrified you about how hard all of this is, let's talk about what we can do. The first thing you need to do when you're testing is figure out how dangerous failure is. how much failure can you tolerate? Are you working in a life-critical industry? Things like medical devices and avionics, they have different regulations. I'm not even talking to those people because their lives are different. And that's good. Like I want that to have a different level of rigor. But if you are a retailer, how much failure can you tolerate? Like none is an acceptable answer, but it's going to be very expensive. Every 9 of uptime that you add to your system is exponentially more expensive because at some point you're buying entire like triple redundant systems, and that may not be worth it for, can I buy plushies online at midnight? So the first thing we need to figure out when we're talking about this is how much failure you can tolerate. Then you want to reduce catastrophes. There's this great, really short paper called How Complex Systems Fail that is actually about reducing medical error. And it basically says that lots of mistakes happen, but a catastrophe, disaster, is when a lot of mistakes pile up. And I think you've probably all had an outage like that where the initial incident didn't seem too bad, and then it hit something that was already fragile, and it just got so much worse. So when we're thinking about reducing our fragility, we need to say, how much can fail without it snowballing, without it getting out of control? And here are some of the ways that you do that. I already talked about circuit breakers. Circuit breakers in electricity are amazing because they keep us from killing ourselves as humans so often. Basically what happens is there's a sudden surge of electricity that shouldn't be there, and a circuit breaker fails, and it fails to a safe state. It says, no, this is a terrible idea, we're not doing that. So when you have a circuit breaker, you're giving yourself a chance to respond to an emergency before it gets out of control, or you electrocute yourself. And then you need to talk about isolation. And you would think that if we're talking about microservices, isolation would come naturally. But like I said, I know that a lot of people doing microservices are actually doing distributed monoliths. And if their database server goes down, or their database service, none of the rest of it works because it's all built to go through the database or query from the database. So when you're thinking about isolations, you have to say, not only how does this work as a system, but if this were completely cut off from the rest of the system, how would it work? And is that acceptable? You want to think about control points. Where in your system can you change how the system is behaving? I sort of think about this as when you're making a meal and you say, I need to adjust the salt in the soup, but I don't need to adjust the salt in the meat. That's like having different control points, even though it's all going to end up on the plate together. If you give yourself more control points to change how the system is behaving, you have a greater chance of stopping a runaway event. And you want to have rapid rollback. All of us have pushed something to production that shouldn't be there and have had the terrible moment where you're like, no, that's terrible. I can't deal with that. Roll it back. And if your deployment process is like 3 days and a war room, it's really hard to do a rapid rollback because you have this momentum that's oppressing you essentially. And so when that happens, you need to think about how you can break up your deployment process so it is closer to CI/CD. Nobody's asking you to do CI/CD tomorrow. That's not how it's going to work. Instead, what we're saying is move toward CI/CD so that you have more control. And the closer you get to it, the faster you can go. And interestingly, we see this in the DORA report, the State of DevOps report, that the faster you go, the safer your deployments are because they're very small. I say that it's really hard to lose $1,000 at penny slots because you're making these really small bets. And eventually it just takes the risk out of it because you're like, okay, I didn't bet $100 and lose 10 times. If I lose 10 times, I only lose 10 cents. And so that's a really important thing to me to say, like, how do you make this whole process less terrifying? And you want to have layered access. My slides aren't advancing, but we're going to post the slides at the end so you can see all my pretty pictures. You want to have layered access that says, like, some people are allowed to change things and some people aren't, because you don't want to have everybody able to change everything. That's terrible information security. And you want to have the ability to basically abstract away what you're trying to do from how you're trying to do it. That's the thing Anton and I are saying to you about the difference between the strategy and the tactics, the semantics and the execution. Because what we want to do in our systems is not only design them to be resilient, but design them to be sort of smarter than us. We can't really make anything smarter than us, but we can make things like the best that we can do with ourselves. So abstractions manage the change rather than having your hands in it. We really now frown on people logging into production servers and changing them like with their fingers from the terminal. We don't do that anymore. We don't change things directly anymore. We do these abstractions to make it safer.
Yeah, I would say probably that's an interesting. Are we trying to make things smarter than us? Probably not. We do want to make machines more predictable than us. And they actually used to be such before we came to this scale, scale of complexity that we now have to manage. And they suddenly became as unpredictable as we are, or even more unpredictable than we are. And that's the main problem with operating those cloud native microservice complex distributed systems that we're dealing with today.
Yes. So all of these things are roadmap, and they are roadmap to reducing the scope of your failures so that they're not disasters, and they're roadmap to adding more touch points so that you can do more CI/CD, so you can really release more quickly. It's not the only map, but it's one that I know of. And when this all goes well, you're going to find that you can take off a lot faster and that you have a lot more control, and it's a lot more predictable, even at scale, because you have more control points to touch it and more places to put analytics and see what's affecting what. And when it goes poorly, it's certainly very exciting. It's very bumpy. And that means that you understand the flaws in your system in a way that you didn't before, but hopefully you have more ways to recover it. The last thing we want is for somebody to do a release after 6 months and find out that it wasn't what anybody wanted or it was broken in some way. I think watching Apple's software rollouts is very interesting that way. I know that, at least for me, my IT department asked me not to install Big Sur yet because they don't know how it's going to work. And I think it might have been more useful for getting uptake if Apple had been willing to release Big Sur like speculatively to IT departments and app manufacturers so that they could get a look at it before the rest of us. So if this talk was too long and you read Twitter, let me sum up for you. Full test coverage is not a thing anymore, and you can tell your boss I said so. Crazy pink-haired lady from the internet says I don't have to write that. That said, what you test is more important than how you test it. And I need you to be thoughtful about the tests that you're doing and make sure that you're actually testing what you want to know about. And and empathetically understanding what people want to experience. I need you to test in production because you're never going to understand how it works without that. And I want you to plan for failure because even if you're perfect, your systems aren't perfect and the things under you aren't perfect. And it is so complicated to understand what you're sitting on top of. And so, given that we're all fallible, we have to count on each other to be fallible rather than being shocked and surprised about it. So I have a t-shirt link. I am not going to guarantee that my marketing department will ship to Russia. I talked to them about this and they said, probably, but if nothing else, we can send you our books on how to do feature management and progressive deployment. So I'll put that link in the chat also later, but it's launchdarkly.com/Heidi. And now we have a few minutes for questions.
Okay, actually, I have a question. So testing in production is also, forward-looking, and it's all very brave talk. And we both realize staging is a misleading and comfortable lie that we tell to ourselves. And still, testing in production is scary and stressful because production is that place where you don't want to touch anything because you don't know what happens when you pull that cable. Right?
Exactly.
So how do you build your production in a way that testing in production becomes less stressful? Because people often don't test in production because they're afraid to break things.
Right. So it turns out practice makes things less frightening. But I'm not saying it's not scary to test in production. It totally is. What we do is make sure that you're not testing for everyone in production. Microsoft calls this ring deployment. And what they do is if you develop something, you test it in your internal group, like your team, and then you test it in like your department, and then you test it with alpha users. The code is always on production, but it's not being revealed to everyone. And that's how you do it safely. So once you've gotten past the alpha users, if it looks like it's going well, then you can automate the rollout so that it goes out to beta users. It goes out to 10% of everyone, 20% of everyone. The release ramps up gradually, which gives you a chance to see if there's any traffic problems or any like edge cases that you didn't catch before it is 100% deployed. And they say this really interesting thing about what finished code is. They say code is not done until it's in production and returning metrics. And I thought that was a really interesting addendum to say, like, what it needs to be doing is return metrics because it doesn't matter what's happening unless we can see it. Unless we can observe how it's behaving, it's not really done. And I was like, no, it is. It's totally done. I launched it. I'm done with it. But metrics are so important for like, did I write that in a way that is compatible? Is anybody using it? If they aren't using it, is there something that I need to change, or do I need to talk to marketing? Like all of these things.
That's interesting. You're taking the space of observability that we all know is necessary. But recently, I've been having a few conversations about, when metrics are actually a burden, because we say, okay, we need metrics coming out of everywhere, and code is not done until it has metrics, but then we find ourselves stuck with loads of metrics, with buckets of metrics, and we find ourselves paying loads of money
So much
for
money.
that metric storage. So how do we know when we need metrics and when we don't, and what's the economics of metric storage?
Right. And it is. It's so expensive. I think one of the things that we do is like, what is this metric testing? If you think of metrics as a test and you do this more mindful, like not not 100% test coverage and maybe not 100% metrics coverage. It's hard to do observability if you're not doing 100%, because like observability in its purest form is being able to ask questions you didn't know when you set up the monitoring. Like you couldn't imagine this question when you set up the monitoring. For that, you need really intense high cardinality data. For beginning to start out with, I don't think you need to put metrics on everything. I think you need to put metrics on the things that affect your users, whether that's performance or even disk space, because if there isn't enough disk space, the application goes down. But again, we need to make that empathetic connection to what people are using our software for.
Yeah, understanding the user. It all boils down to that. So another interesting thing, actually, what you were talking about a minute ago is progressive delivery, isn't it? Like that whole story of Microsoft gradually rolling out functionality to their internal and then sympathetic and then other users. So if I understand correctly, there is a way of doing progressive delivery with feature flags, and that's basically what Launch Darkly is about. And we all know there's another way of doing this with smart traffic control. The different kind of API gateways, ingress controllers, service meshes, you name it, deal with. So are there pros and cons of each of these approaches in your eyes?
Well, let me say I'm from a vendor, so I have an opinion. The thing that you don't get with traffic shaping is it's very difficult to track the experience of one user. And if you're using feature flags, you can frequently identify a unique user and track their experience all the way through. Whereas if you're using traffic shaping, it sort of depends on where somebody came in that day. Like if they are on mobile or on web, they may have a different experience because those are different traffic nodes. Whereas if you're using a feature flagging system, you have a unique user ID, and once somebody gets a variant, they always get that variant, so they don't have a mixed experience.
Okay.
If it isn't important to you to have that very solid experience, then I think traffic shaping is a great way to do large scale testing, less fine grained.
Okay. So another question is, what are the biggest problems with feature flagging that you've seen? What are the biggest catastrophes, maybe, feature flagging that you've observed?
So the canonical how feature flags fucked up story is Knight Capital, KNIGHT, who reused a feature flag name and then turned it on accidentally in production and started doing a bunch of trading. And in their panic, they didn't turn off the correct one, they turned the bad one on for the rest of their servers. So they ended up trading away their entire market capital in about 45 minutes, millions and millions of dollars. And it would be not easy, but it's certainly like possible to see how you do that. So one of the things that we're really clear on is like you need to never reuse a flag name because you don't understand what it's going to do next time. And you need to do a lot of technical debt cleanup. This is one of the things that I hear a lot. It's like, how do you manage the technical debt of having all these flags in your code, even if they're 100% deployed? And the thing that we tell people is, well, maybe don't leave them lying around in your code because they're a threat surface. Like if it's something that's for a deployment, a temporary rollout, a progressive deployment, then after it's 100% deployed, pull that code out. You don't need to have a feature flag for that because it's already out there.
That's interesting. Is there any kind of code scanning that tells you how many feature flags you have and maybe warns you that you have feature flags that need to be deprecated or
Launch
taken
Darkly
out of
does,
the
and we
code?
even tied it into, we even tied it into a Slack bot so that it will pop up and say, hey, this flag has been fully deployed for 30 days, maybe take it out. I don't know what the other feature flag vendors do. I think it is possible, even if you're rolling your own system, to set it up to do that, but you have to be aware that it's something that you need to pay attention to. If you're giving flags a consistent syntax, I mean, you can scan your code base for them.
Okay. So what Launch Darkly does, it monitors the flags that are already in production.
Yes.
Yeah, I was thinking more.
And it gives you, for all the Git-based code repositories, it gives you a link. So you can say, show me where this is in the code, like all the places this occurs.
Wonderful. Interesting. I have no idea about what Launch Darkly does, how it works. I have no experience with it, but the thing you just told makes it really interesting to try.
Excellent. Well, I'm gonna be in the Zoom chat afterwards. So if you want to talk more about it there, or if you have other stuff to do, you could go do that. But I think we're about out of time. Thank you all for coming.
Yep, to the discussion zone.
Yep. So thank you, Heidi. Thank you, Anton. Thanks for very interesting and inspirational talk. So yeah, as Anton and Heidi already mentioned, there's a discussion zone. You have this camera icon right under your video. Please click it, and the Zoom application should pop out. So you can find our expert and our speaker there and ask whatever you want about feature management or microservices and so on. So I think that's it. So thanks again for the talk. It was great to have you both here today.